which is that. So all these signs, you are very well conversant with them. And whole numbers, just as the name are saying, whole numbers.
Saa 1:30 jioni tarehe 23 mwezi wa 10 mwaka 2023, Mheshimiwa Babu Owino, mbunge wa Embakasi Mashariki, akifanya kwake tena katika nyakati hizi za mitihani. Babu Owino aliwafundisha wanafunzi watahiniwa wa grade ya 8 KCPE mwaka huu somo la hisabati.
The numerator is the number that is.
Babu Owino akisisitiza kwamba practice makes perfect, akiwarai wanafunzi kulipenda somo la hisabati, wafanya mazoezi ya dakika 40 kila siku ili kuwawezesha kukabiliana na mtihani unaokuja. Babu Owino akijipiga kifua kwamba hapa ndipo anatoa mafundisho ya bure. Mheshimiwa Babu Owino amekuwa akiwasaidia wanafunzi hasa katika somo la hisabati katika mitihani ya KCPE na KCSE katika marejeleo.
Thank you very much, fellow Kenyans. I'm Babu Owino, Member of Parliament, Embakasi's constituency. Today, being the 23rd of October 2023, I want to take this opportunity to revise with our candidates. That is the KCPE mathematics revision. The main reason why I'm doing this is to motivate our children, is to motivate our candidates to pass examination, to let them know that it is possible. If Babu Owino came from Nyalenda slums, from selling changa, and now is in parliament, then you as a candidate, you can make it. You can be a doctor, you can be a nurse, you can be an engineer, you can be a teacher, you can be an economist, you can be an advocate. So the most important thing is just the mental thinking. Always be positive, always speak positive, always know that it is possible. If others have done it, you can do it. And I can assure you today, as a candidate, if you are coming from Turkana, if you are coming all the way from Northeastern, you are coming from Central, Nyanza, Western, Coast, Nairobi, and any other part of this country, Eastern region, know that it is possible. Know that you can make it. Have confidence always, and always put God when you are doing everything. Because the Bible says that you seek ye unto the kingdom of God first, and every other thing shall be added unto you. As our children, my role is to help you pass exams, is to help you make it in life. We know that you can make it. Only the positive mentality. Remember always that positive thinking produces positive results, while negative thinking produces negative results. I know that you will be confident enough to pass KCPE examination with flying colors. You will proceed from primary school to secondary school, from secondary school to the university. And I believe that one day you shall be somebody in this nation. Our parents are struggling so much so that they can put food on our table, so that they can pay our rent, so that they can pay our school fee. But I believe that one day you are the light of that family. You are the person who is going to remove that parent from the slums to a better place. You are the person who is going to remove that family from the village to a better place. And to our parents, let's continue nurturing our children. Let's never give up on them. Let us help them. In mathematics, we say practice makes perfect. Between now and November, when you'll be doing your exams, make sure that at least on a daily basis, take 40 minutes and revise mathematics, or take 40 minutes and revise that subject which is of an issue to you. There's nothing difficult, only thinking makes it so. If you believe it is easy, it is easy. Now, let's now get to business. Today we want to deal with whole numbers and fractions. What I simply did was to collect different questions from the past papers that we've always done, the KCPE past papers that we've done before. And I've decided to collect the commonly set questions. And those are the questions that we're going to revise here. And these are the questions that when you handle them well, will never miss in these exams. I can assure you. Maybe the question will be just paraphrased, but the same mode of setting. Expect that, and always just be positive. Remember, So in these whole numbers and fractions, I can assure you that so many questions are going to come from this, and you will be smiling when you are going to get your results. So in whole numbers and fractions, we will deal with their applications. So today being the 23rd of October 2023. So we'll deal with the whole numbers and fractions. So when we handle whole numbers first, in whole numbers, we'll just deal with the applications. The commonly used signs here are addition sign, which you all know, that is the sign. The second one is subtraction. Which is that sign. The third one is multiplication. Or also called the product, which is that. And the next one is the division. Which is that. So all these signs, you are very well conversant with them. And whole numbers, just as the name is saying, whole numbers. And numbers like 1 on a number line, 1 to 10 or 1 to 9. And also there are also negative whole numbers. When you check the number line, if that is 0, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, and it goes. On the other side, we have negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, and you go on and on and on. Then we have what we call fractions. We have different types of fractions. Number one, we have proper fractions. Proper fractions are fractions like a half, 3 over 5, 5 over 6. These are fractions where the numerator is smaller than the denominator. The numerator is the number that is up. This is the numerator. This is the denominator. So the numerator is smaller or less than the denominator. And the denominator is greater than the numerator. In simple terms, the numerator is smaller, is 1. The denominator is bigger, is 2. You come here, the numerator, 3 over 5. The numerator is smaller. The denominator is 5, which is bigger. Then the next type of fraction is improper fraction. Improper fractions. In improper fractions, this is just the opposite of a proper fraction. So in an improper fraction, the numerator is bigger than the denominator. So the numerator is the number that is up, denominator is the number that is down. So if we have a fraction like 3 over 4, 4 is the numerator, 3 is the denominator. So in a improper fraction, the numerator, which is 4, is bigger than the denominator. So examples of improper fractions are 3 over 2, 5 over 3 is improper. 6 over 5 improper fractions. Then the next type of a fraction again is mixed fractions. Mixed fractions, which are also called whole fractions. So in a mixed fraction, it is a mixture of a whole number and a fraction. A mixture of a whole number and a proper fraction and a fraction. A mixture of a whole number and a fraction. Then the last type of fractions is reciprocal. Reciprocals. So if you have a fraction like 3 over 4, the reciprocal of 3 over 4 is 4 over 3. You just, the numerator becomes the denominator and the denominator becomes the numerator. Another example, if we have 2 over 3, reciprocal of 2 over 3, the numerator becomes the denominator and the denominator becomes the numerator. So these are different types of fractions that we have. So in our situation, if you are given these types of fractions, then we need to make an application. If you are given different numbers, different signs, then we need to apply what we call BODMAS. BODMAS. BODMAS means brackets of division, multiplication, addition, subtraction. Bracket of division, multiplication, addition, subtraction. So in whole numbers and fractions, you will notice that we will use a lot of this so long as you are given more than one sign in a sum or in a problem to solve. At an advanced level, we use what we call BIDMAS. In advanced level, you don't need to focus on this, but just because you will be advancing very soon, BIDMAS means brackets, indices, division, multiplication, addition, subtraction. That is what we call BIDMAS. But let us not focus on this. This is what you're going to use in your examinations. Whenever you see a sum with different signs, that is addition, subtraction, multiplication, and division, and also brackets, you will use BODMAS. So now, let's focus on examples without wasting any time. So we go to question 1. And also in whole numbers, we will be dealing with place values. Place values. So, question 1, how many groups of 10 would represent the value of digit 6 in the number? So question 1, how many groups of 10 would represent the value of digit 6 in the number 36,974? So the keyword here is how many groups of 10 would represent the value of digit 6 in the number 36,974. So first of all, let us identify the value of 6 in this number. So the value of 6 in this number, we start with here. This value is ones, tens, hundreds. Then here is thousands. Then 3 is tens of thousands. So when we want to look at the value of 6 in this number, you just simply take 6 is in thousands. So it is 6. Then the other values replace with 0. So where there is 9, 0. Where there is 7, there is 0. You put 0. And where there is 4, you put 0. Therefore, the value of 6 in this number is 6,000. Then the question says, don't stop there, because this is just the value of 6 in 36,974. So the question wants, how many groups of 10? So how many groups of 10? You simply divide 6,000 by 10. So you get 600. So 600 of them. So how many groups of 10? So 600 groups of 10 represent the value of 6 in this digit of 36,974. So the answer is 600. So that's question 1. Then we go to question number 2. So you write 600 groups. Question number 2. So question number 2, what is the place value of digit 2 in the product of 9,040 and 5? So listen to the question carefully. What is the place value? The question wants the place value, but place value of what? Of digit 2 in the product of 9,040 and 5. The key word here is product. Product means multiplication. So first of all, the first step is to multiply 9,040 by 5. So 9,040, you multiply by 5. 0 times 5 is 0. 5 times 4 is 20. You write 0, you carry 2. 5 times 0 is 0, plus 2 is 2. Then 5 times 9 is 45. So our number here is 45,200. So the keyword is product. So once you get product of 9,040 and 5, you get 45,200. Therefore, go back and read the question. The question now is asking, what is the place value of digit 2? Place value of digit 2. So you place these ones. So the first value here is ones. The next value is tens. The next value is hundreds. The next value is thousands. The next value is tens of thousands. So the question is asking, what is the place value? Place value of digit 2. So the place value of digit 2 is hundreds. Hundreds. So our answer is hundreds. Question number 3. Now question 3. So as I read the question is projected on the screen so you can easily see. So question number 3, multiply. Remember, we are dealing with whole numbers, so it's about just playing with the addition sign, subtraction, division, multiplication. So multiply 2,465 by 234. By 234. After multiplying the question once, what is your answer rounded off to the nearest 10,000s? That is rounding off. Is also an application in this. So first of all, you multiply this. So in the multiplication, you need to be a little bit fast because there is no time. You have many questions and there is no time. So you need to be slightly faster. So 5 times 4 is 20. 0 carry 2. 4 times 5 is 20. 4 times 6 is 24. Plus 2 is 26. 6 carry 2. 4 times 4 is 16. Plus 2 is 18. 8 carry 1. 4 times 2 is 8 plus 1 is 9. Then 3 times 5 is 15. Write 5 carry 1. 3 times 6 is 18. Plus 1 is 19. 9 carry 1. 3 times 4 is 12. Plus 1 is 13. 3 carry 1. Then 3 times 2 is 6 plus 1, 7. So you can just add 0 here so that you make them uniform, but I'll explain that. 2, now we are done with 4 and 3, you go to 2. 2 times 5 is 10. You put it down here where 2 is, 10, 0, carry 1. 2 times 6 is 12, plus 1 is 13, 3, carry 1. 2 times 4 is 8, plus 1 is 9. Then 2 times 2 is 4. Then you add them. So where there is nothing here, you just replace with 0 for ease of addition. You can equally write 0 here. 0 before a number is nothing when there is no decimal point. When there is a decimal point, the value changes. But when there is no decimal point, then it's just nothing. But 0 after number is something. Okay? So when we add them, 0 plus 0 is 0. 6 plus 5 is 11. 1 carry 1. 8 plus 9 is 17. Plus 1 is 18. 8 carry 1. 9 plus 3 is 12. Plus 3 is 15. Plus 1 is 16. 6 carry 1. 7 plus 9 is 16. Plus 1 is 17. Carry 1. 1 plus 4 is 5. So our number is 576,810. So what does the question want? First of all, you multiply. As you multiply, the next step is, what is your answer rounded off to the nearest 10,000s? First of all, identify the place values of all these numbers. The place value of 0 is ones. Place value of 1 is tens. Place value of 8 is hundreds. Ones, tens, hundreds. Next is thousands. Next is tens of thousands. Next is hundreds of thousands. Again, identify the place values of these numbers. For 0 is ones, 1 is tens, then hundreds, then thousands, then tens of thousands, then hundred of thousands. So the question is asking, what is your answer rounded off to the nearest 10,000s? So come here and identify, where does tens of thousands lie? It lies here. Therefore, we want to round off this value, this number, to the nearest tens of thousands. If you're told to round off to the nearest tens of thousands, look at the next number. Careful class, look at the next number, which is thousands. So if this number is thousands, this is our point of concentration. If you're told to round off to the nearest tens of thousands, look at the next number, which is 6 in thousands. Okay? Then this number, class, in a number line, we have 0 to 5 to 9. If this number that we are focusing on is less than 5, or is the number more than 5? So be careful. If the number is more than 5, which it is 6, then the next tens of thousands increases by 1. Class, careful. If you're told to round off to the nearest tens of thousands, look at the number before it, which is thousands, which is 6. If this number 6 is more than 5, is between 5 to 9, Then when we round off, we move to the next place value. So the next place value, we add it by 1. The next place value, which is 7, our focus point, we add it by 1. So our answer becomes 58. Then all these other numbers are replaced with 0. 1, 2, 3, 4. They are replaced with 0. 1, 2, 3, 4. So this is our answer. Okay? 4. We replace with 0. Now, this is our answer. Suppose this number, class, suppose this number is 4. We finished this. Now, suppose this number is 4. So we will have 57. Then suppose this number is 4. 810. Then you are told to round off to the nearest tens of thousands. So this is thousands and this is tens of thousands. So if it is to the nearest tens of thousands, look at this number. If it is less than 5, then the value of this number, the tens of thousands, which is our focus 7, remains the same. So our answer will remain 57. Then you replace all these 4 numbers by zeros. 1, 2, 3, 4. So our answer would be that. So the only point of focus here is to look at 5. If the number is 5 or more than 5, then our next number increases by 1. If it is between 0 and 4 or less than 5, then the number remains the same. Very good. So if you are told the same number, this question can come in different ways. You can be told to round off to the nearest hundreds. If you are told to round off to the nearest hundreds, remember class, I told you look at the next number, which is now tens, which is less than 5. If it is less than 5, then you round off this to the nearest hundreds. Then this number will remain 57. It will be 57 because it will not add any value there. Then this and this will be 0, 0. So you must be very careful. So if you are told to round off 810 ones, tens, hundreds to the nearest hundreds, you look at this number. If it is less than 5, this will remain to be 800. If this is more than 5, for example, it is 5 or more, then this will increase by 1. So it will be 900. So I think we can move to the next question. What is the sum total value of digit 3 and 9 in the number 7803,925? This is question 4. So what is the sum of the total value? Sum. The keyword here is sum. Sum means addition, the total value. So what is the total value of digit 3? So first of all, identify these ones. So this is ones, tens, the place value, hundreds, thousands, tens of thousands, hundreds of thousands, then million. So what is the place value of digit 3? First of all, digit 3, we have thousands. So you write it 3, then just replace the other numbers with zeros. So that is 3,000. Then what about digit 9? Digit 9 is in hundreds. Then it is just 900. 900. So this is for digit 3 and this is for digit 9. Then the question is asking, what is the sum of the total of this and this? Sum of the total, you simply add them. So this is 0, 0, 0 plus 0 is 0, 0 plus 9 is 9, then 3. So this is our answer, 3,900. Then we go to question 5. Which one of the following numbers, question 5, which one of the following numbers is 7 million? Now, you've been given a problem in words. They want you to write in numbers. So they want 7,30,265. So just come, write 7 million. That is 7 million. The next is 7,30,000. 30,000. That is 30,000. 200. 200. And 65. 65. So just add these ones. 0 plus 5 is 5. 0 plus 6 is 6. 0 plus 2 is 2. Then 0 plus 0 is 0. 0 plus 3 is 3. Then 0 plus 0 is 0. Then 7. So this is our answer. So that is number 5. Then is there any, according to my paper here, this is number 5. Then there's another one, which is, which one of the following is it that one? Yeah. So, question 6. So, class, there's a we've mixed up the numbers, but that's okay. So just get this question. Which one of the following numbers is 7 million? Write 7 million. 30,000. 265. You are given this question in words. Then they want you to write it in numbers. So simply write them in numbers. 7 million separated, 30,000 separate, 200,000 separate, 200 separate, and 65. Then add them. This is our answer. Then what is showing on the screen is now question 6, which you are shown as question 5. So here my question 6 is, which one of the following is, now you've been given numbers. They want you to write in words. So the number that you've been given is this. Okay? This is the number that you've been given. They want you to write it in words. In words, just separate these numbers. Separate these numbers. 7, so we have ones. The place value for 7 is ones, then tens, then hundreds, then thousands, then tens of thousands, then hundreds of thousands, then a million. So what do we write here, class? We have 7 million. 7 falls in millions, so we have 7. Then just write it like that. Sorry. $7 million. Then come here. This is 77,000. So we have 70,000. This 7 is in thousands. So this is 70,000. Then 7 is in thousands. So 7,000. Then we have tens, which is 0. Then we have 7. So this is, just write it down, 7 million. Then the next one is 70,000. Then write the next is 7,000. Then next is 7. So combine this. Because you've been given in numbers, combine in words. So it is 7 million, then we have 70,000, then 7,000. So this is 77,000. So our answer is 7 million, then 77,000. 77,007. Sorry, class, sorry. We have hundreds, which is 700, sorry. Then we have 7, sorry. So 700, then 7. So we have 7. Just let's start it, class. Ones, tens, hundreds, thousands, tens of thousands, hundreds of thousands, then a million. So separate them. 7 is in 7 million, is a million. Then this 0 is hundreds of thousands, so it is 0. Then you go to the next number, which is 7. It is in thousands, but it is 70,000. So it is 70,000. So you write here 70,000. Are we together? Then after that, we go to the next value, which is 7 in thousands. So it is 7,000. Then the next value is 7. We didn't write this when we were solving it. The next value is 7. It is in hundreds, which is 700. Then the last one is 7, which is ones, 7. So the answer is 7,077,707. So 7,077,707 I think this is proper. 7,077,707. That is proper. Then we go to question 7. So anytime you are given such a problem, please just get the place values. Then after that, line them up this way. Then write the values in words. And then combine these words together. So we go to question 7. So question 7 is, what is the value of 3 into, are we together? Is that the question? Okay. Write the value of 3 bracket 5 squared minus 4 squared, close the bracket, plus 51 divided by 17. So what does this question want? I told you when you're given whole numbers and it involves more than one sign, you use what we call BODMAS. So this is an application of BODMAS. So BODMAS is bracket. So first of all, solve what is in the bracket. So what is in the bracket is 5 squared minus 4 squared. So when you open the bracket, 5 squared means 5 times 5, which is 25. Minus 4 squared means 4 times 4, which is 16. The answer is 9. Therefore, come back and replace 9 here. So we will get 3 into bracket, it is still there, 9, plus 51 divided by 17. Then bracket of, the next one is of. So it is 3 of. This bracket 3 in bracket 9 means 3 of. So it means 3 times 9, which is 27. Then again, rewrite it, plus 51 divided by 17. We finish with of, then we go to division. So what is being divided here is 51 divided by 17. You take it with its sign. So we have 51 divided by 17. So you can use cancellation. So 17 goes here once, it goes here 3 times. Or you use long division. So we've solved this. 51 divided by 17, you get 3. Then rewrite it again. 27 plus the answer 51 divided by 17 is 3. Then you go to, we don't have multiplication, and then we have addition. So addition is 27 plus 3 is 30. So that's question 7. Then we go to question 8. Question 8. What is the value of 549 minus 243 divided by 27, then over or divide by 27? So this question, they want the value of this. Again, an application of BODMAS. So you write BODMAS. So such a question, this is our numerator and this is our denominator. So first of all, solve everything on the numerator, then divide by whatever is on the denominator. So BODMAS, bracket, we don't have bracket, off, we don't have off, division, we have division. So what are we dividing? We are dividing 243 divided by 27. So if we use long division, 243 divided by 27. So how many times does 27 go into 243? This is 9 times, which gives you 243. If you subtract, you get 0, 0. So the answer is 9. Or use cancellation, which is 243 divided by 27. When you are dividing using cancellation, you use the least prime number. So the least prime number that can go in 243 and also go in 27 without a that can go in both 27 and 243 is 3. 3 here, 3 goes into 27 9 times. 3 goes into 24 8 times, then into 3 once. Then you'll have 81 divided by 9, which is equal to 9. 9 goes here once, 9 goes here 9 times. So therefore, we have 549. Rewrite it, minus, if we divide 243 divided by 27, we get 9, minus 9, then divide by 27. So here, bracket is not there, of is not there, division we've already divided, multiplication is not there, addition is not there, subtraction is there. So it is 549 minus 9, you get 540. Divide by 27. Okay? So when we divide this, we can take the least prime number, which is 3. 3 here, 9. 3 goes into 5 once, remainder 2. 3 goes into 24 8 times, then 0. Then 9 goes into 9 once, 9 goes into 18 twice, then 0. So this is 20. So our answer is 20. Or long divide, 540 divide by 27. 27 goes into 54 into 5 0 times. But it goes into 54 twice. Then it goes into 0 0 times, which is 540. 0 0 0. So our answer is 20. Question 9. What is the value of, question 9, what is the value of 24 into 72 minus 69 plus 6 times 4 divided by 12? So class, apply BODMAS. BODMAS is bracket. Yes, we have bracket. Bracket is 72 minus 69. So we have 24 into 72 minus 69 is 3. Rewrite it, plus 6 times 4 over 12. I told you such a question, solve the numerator first, then deal with the denominator. So the numerator, we've dealt with bracket, yes. Now of is 24 into 3, means 24 times 3. Of means times. 24 times 3 is 72. Replace this one, times plus 6 times 4 over 12. When you come down here, of division, we will not go to division This is division, but we have to solve the numerator first. That's when we'll come to division last. So we will not deal with this division, but if there was division sign in the numerator, we would have dealt with it. Then we go to multiplication. So the multiplication that we have here is 6 times 4. So we have 72, then plus 6 times 4 is 24. Divide by 12. Then we go to addition. Add the numerator, that is 72 plus 24, that is 96. So we have 96, then divide by 12. So you don't leave your answer in this form because this is not simplified. So when you simplify it, use the prime numbers. 2 here, 6 by cancellation, 2 here, 48. Then 2 here, 3, 2 here, 24. 3 here, 1, 3 here, 8. So 8 over 1 is the same as 8. So that is our answer. Question 10. Question 10. What is the value of 8 squared into 9 squared minus 3 squared divided by 4 squared times 6 squared? So class, what is the value of this? This is simply asking us to simplify. As usual, BODMAS. So in BODMAS, we have bracket. So what do we have in the bracket? We have 9 squared, which means 9 squared means 9 times 9 minus 3 times 3. 9 times 9 is 81 minus 3 times 3 is 9. So 81 minus 9 is 72. Okay, so come and rewrite 8 squared into 72 divided by 4 squared times 6 squared. So instead of simplifying the numerator then dividing by the denominator simplified, and we know that this one we can deal with this by cancellation, because 8 squared into bracket 72 means 8 squared means 8 times 8, then times 72. Divide by 4 squared means 4 times 4 times 6 squared means 6 times 6. So this can be dealt with when we simply do cancellation. So 4 goes here once, 4 goes here twice. 4 here once, 4 here twice. 2 here once, 2 here 3. 2 here once, 2 here 3. 3 here once, 3 here twice. 3 goes into 7 2 times, which is 6, remainder 1. 1 you bring it here, it goes into 12 4 times. Then 3 here once, 3 here 8 times. So the answer is 8. Question number 11. What is the value of 6 squared minus 6 divided by 3 plus 3? So class, be very, very careful. When you look at this question, look at where this division sign reaches. It's not covering 3. It's only covering up to this point. Then plus 3 is outside. So what you are required to do is to solve what is here first. Then you add it to 3, because 3 is left outside this. So solve the numerator of this. 6 squared means 6 times 6, which is 36, minus 6, divide by 3, plus 3. 36 minus 6 is 30, divide by 3, plus 3. So you can notice the difference. This division sign does not cover 3. Therefore, we will only work out this first, which is 30 divided by 3 is 10. Then you add to 3. You get 13. So this is different when it is written like 6 squared minus 6 plus 3 divided by 3. You have to be very careful on where the division sign ends. If it were this way, then you would have started with the numerator, which is, you square this first, is 36 minus 6 plus 3 divided by 3. Then you use BODMAS. Bracket is not there, of is not there, division is not there, multiplication is not there, addition. Therefore, you add 36 plus 3. You get 39 minus 6 divided by 3. So 39 minus 6 is 33. Divide by 3, you get 11. This and this are totally different. The question is asking us this. So you separate and solve this side first, then you add it to 3. So the answer that is required is 13. But you find that in your choices, because you will be given choices, you will find this answer also available. So which means that you started by solving the numerator all, which is wrong. Okay? So this is the right way to solve this. Question 12. We're almost finishing, so just be with me, please. Question 12. What is the value of 6 into 24 minus 18 plus 6 times 4 divided by 6? BODMAS. These questions on BODMAS, they will come, so many. So start, remember this is covering everything. So you start with the numerator, bracket, solve bracket, that is 6 into 24 minus 18. We solve what is in the bracket, is 6. Plus 6 times 4 divided by 6. Then of, bracket of, that is 6 of 6. 6 times 6 is 36. Plus 6 times 4 divided by 6. Next step is 36. Is division is not there. We will divide last. Then multiplication. 6 times 4 is 24. So plus 24 divided by 6. Then addition. 36 plus 24 is 60. Divide by 6. You get 10. So these things are so easy. So easy. You can get 101 out of 100. You know, you can score 100% and the examiner decides to add you 1% for good job. If that examiner is, is generous enough. Then we are going to another part, which is the LCM, GCD, or HCF. LCM means least common multiple. GCD means greatest common divisor. HCF means highest common factor. So highest common factor and greatest common, the GCD are the same. HCF and GCD are the same. So question 13. What is the product? These are applications of whole numbers. What is the product of the LCM and HCF? HCF means highest common factor of 10, 20, and 40. So number one, before you do anything, get LCM. So in getting LCM is the least common multiple. Therefore, we use the least factor, the least common factor. The least factor that when you divide by this, you can easily divide without any problem. So the least one, we start with 2. Least factor is 2. 2 goes into 10, 5 times. 2 goes into 20, 10 times. 2 goes into 40, 20 times. Then, because we are dealing with the least, we've not exhausted 2, because 2 can still go in 10 and 20. So do use 2 again. 2 can go into 5, but there is a remainder. So just bring down 5. Then 2 can go into 10, 5 times. 2 goes into 20, 10 times. Then before we go to any other, you do 2 again. 2 can go into 5, but there will be a remainder of 1. Therefore, just drop 5 down. Again, drop 5 down. Then 2 can go into 10, 5 times. So we have a common number here, which is 5. Now we can't use 3. We can't use 2 again because there will be a remainder, remainder, remainder. We can't use 3, remainder, remainder, remainder. We can't use 4. Therefore, we use 5. 5 goes into 5, 1, into 5, 1, into 5, 1. Once you reach 1, you stop there. Therefore, our LCM, the least common multiple, is 2 times 2 times 2 times 5. This is 8 times 5. 2 times 2 is 4. 4 times 2 is 8. 8 times 5 is 40. That is our LCM. Then find the GCD, which is the same as the highest common factor. So, highest common factor of 10, 20, and 40. First, start with the least factor. The least factor that can divide all these without a remainder is 2. 2 goes here 5 times. 2 goes here 10 times. 2 goes here 20 times. Remember, the highest common factor, we want the highest value that can divide these numbers without a remainder. Whenever you see a remainder, you stop there. So, the highest number here, if you use 2, then there will be a remainder here. So, we will not work with 2. If you use 3, there will be a remainder in all. You don't go to 3. If you use 4, there will be a remainder in all. If you use 5, 5 can divide all this without a remainder. So, the next one is 5. Then 5 into 5 once, 5 into 10 twice, 5 into 20 4 times. You stop there because there is no any other number that can divide all this without a remainder. If you use 1, it will remain the same. If you use 2, there will be a remainder here. If you use 3, there will be a remainder here. So we stop it at that. So the highest common factor is these two values, that is 2 multiplied by 5, which is 10. This is the highest common factor, or the GCD, the greatest common divisor. Then the question says, what is the product of the LCM and the highest common factor? Don't stop there. The product means multiply. What is the product of? What is the LCM multiplied by the GCD? The LCM is 40. Multiplied by the GCD is 10. You get 400. That is our answer. Question number 14. Only 7 more questions, so just slightly be patient. Question number 14. What is the greatest number that can divide 30, 45, and 60 without a remainder? What is the greatest number that can divide this without a remainder? Greatest number, GCD, greatest common divisor, or the highest common factor. So they want the GCD. The question simply wants the GCD. So start with the least prime factor. If you use 2, 2 can divide this, yes. But 2 will divide this with the remainder. 2 will divide this perfectly. So there's a remainder in this, so we drop 2. Therefore, go to 3. 3 can go into 30 10 times. 3 can go into 45 15 times. And 3 can go into 60 20 times. Then, can 2 go here? Yes. Can 2 go here? No. It will go, but there will be a remainder. So we drop 2. Then use 3. Can 3 go here? Yes. It will go 3 times, then there will be a remainder of 1. Can 3 go here? Yes, 5 times. Can 3 go here? Yes. It will go 6 times, then there will be a remainder of 2. Therefore, we drop 3 also, because there is a remainder that it brings on both the numbers. Then go to 4. 4 can go into 10 2 times, remainder 2. 4 can go into 15 3 times, remainder 3. 4 can go into 20 5 times. So there is a remainder in 4. What about 5? Let's see 5. 5 can go into 10 twice. 5 can go into 15 3 times. 5 can go into 20 4 times. Then you stop there, because there is no any other number that you will use to divide these numbers without a remainder. You will get a remainder. So you stop it there. Therefore, you get the 2 digits, that is 3 times 5, you get 15. So this 15 is the only number, the greatest number that can divide these numbers without a remainder. Let's see if it is true. 3 divided by 30 is twice. No, sorry, 15 divided by 30 is 2. 15 divided by 45 is 3. 15 divided by 60 is 4. So it can divide successfully without a remainder. So the answer is 15. Question number 15. Question 15. By how much is the LCM? By how much? By how much difference? By how much is the LCM of 40 and 60 more than their GCD? First of all, get the LCM. LCM of 40 and 60, the least factor is 2, 2 here, 20, 2 here, 30. Go to 2, 2 here, 10, 2 here, 15. We can't use 2, there will be a remainder here. We can't use 3, there will be a remainder here. We can't use 4, there will be a remainder in both. Now we go to 5. 5 goes here twice. 5 goes here. No, sorry. We go to 2. The LCM first. LCM you exhaust. LCM ensure that the last values are 1. LCM, the least common multiple. So we can still use 2. 2 goes here, 5. Then bring down 15. Don't bring it down with the remainder. Just bring down 15. Okay? So we have 5 and 15. 3. From 2 we go to 3. 3 goes here, but there will be a remainder. Remember, we are doing LCM. So you just drop down 5, but 3 goes into 15 5 times. Then 5. 5 goes here, 1 and 1. LCM you ensure that you remain with 1 and 1 because we want the least common multiple. Therefore, you just multiply 2 times 2 times 2 times 3 times 5. 2 times 2, 4. 4 times 2, 8. 8 times 4, 24. 24 times 5, 120. Then get the GCD. This is LCM. Then the GCD of 40 and 60. First of all, use the least factor, that is 2. 2 goes here, 40. 20. 2 goes here, 30. Then 2 again. 2 goes here, 10. 2 goes here, 15. Now we can't use 2. If you use 2, then you will be finding the LCM. Remember, we want a common number that can divide these two successfully without a remainder. So 2 cannot. 3, there will be a remainder here. 4, there will be a remainder in both. Therefore, the next one is 5. 5 goes here twice. 5 goes here 3 times. So we have 2 and 3. You stop there. Why? Because there is no any other number that can divide these two without a remainder. So you stop there. Therefore, the GCD is 2 times 2 times 5. 2 times 2 is 4. 4 times 5 is 20. But what does the question want? The question says, by how much is the LCM more than the GCD? The LCM is 120. The GCD is minus 20. So it is 100 times more. They just want you to get the LCM and the GCD and get the difference. So they're just playing around with your mind, but it's just about LCM and GCD. So by how much? What is the difference? Question 16. We have 5 more questions, but very important and urgent. Question 16. Be very careful here. There's something I want to tell you which is very, very important in this question. And it's very common. It's just testing your IQ, your intelligence quotient. Question 16. A farmer sold milk from 9th of December 2015 to 9th of March 2016. December 2015, 9th to March 9th 2016. How many days did the farmer sell the milk? How many days did the farmer sell the milk? Just write the months. Write December 2015. Then January, February, March. So these three are 2016. But remember, the farmer started selling, a farmer sold milk from 9th. On 9th of December, he sold milk. On 9th, he sold milk. He's asking you, how many days did the farmer sell the milk? How many days in total did he sell the milk? So on 9th of December, he sold the milk. But on 8th of December, he did not sell the milk. From 1st to 8th of December, he did not. But on the 9th of December, he sold the milk. Are we together? Then January, the whole month, he sold the milk. January has got how many days? 31 days. Then March, he sold up to 9th. Then this February, how many days did he sell the milk in February? I know this one, even a person probably in the university might miss it, because it needs a little bit of reasoning. Remember, how many days are there in February? Normally is 28 days. But in our situation, there are 29 days. Why? Because it is a leap year. Then how did we know that it is a leap year? Leap year comes after every 4 years. And a year that is divisible by 4 is a leap year. Are we together? Let me explain again. You have to know, you have 2015 and you have 2016. So you have to first identify, this February, was it a leap year in 2016 or was it a normal year? But what is a leap year? Leap year falls after every 4 years. But how will you know it is a leap year? When that year is divisible by 4. When that year can be successfully divided by 4 and itself. So, when you take 2015, if you divide by 4, there will be a remainder. But when you take 2016, you divide by 4. 4 year once, 4 year, 5 times into this, 0 here, 4. So 4 goes into 2016, 504 times. So it can successfully divide, which means this was a leap year. So these are 29 days. Then come back here. He sold milk from December 9th. From December 9th, which means he did not sell on 8th. So how many days did he sell the milk? So you count from 9th December to 31st December. So start with 9 to 31st. Is the same as 31 minus 8, which is 23 days. If you subtract 31 minus 9, you will get 22. But remember, that is the difference. But he sold it on the 9th, from 9th. So you add 1, you get 23 days. Then here, 31 days in January. Then 29 days because it is a leap year. Then 9 days in March. From 1st of March to 9th of March. So 9 days. Then you add them. So you add 23 plus 31. You get 4, 54 plus 29. You get 13 carry 1, 83 plus 9. You get 92. So this farmer, how many days did the farmer sell the milk? 92 days. So the key word here is, this February you ensure that you ensure if this year was a leap year or not, you will get the number of days. So you don't confuse whether it is 28 or 29. If it is a leap year, as it is, 2016 is 29 days, February. Then 2015, December, he started selling from 9th to 31st. When you count from 9th to 31st, you get 23 days. Then you add all the days, 23 plus 31 plus 29, plus 9 days in March. You get 92 days. Just 5 more, but very important. The next question. Question 17. A 26-bus seater and an 18-seater matatu were hired to transport 502 people to a sports meeting. Both vehicles traveled together, but the matatu made the last trip alone. How many people altogether did the matatu transport? A 26-seater bus and an 18-seater matatu were hired to transport 502 people to a sports meeting. Both vehicles traveled together, but the matatu made the last trip alone. How many people altogether did the matatu transport? First of all, we have a bus. Hii ni nganya. Ama hii haifiki hiyo kiwango ya nganya bado. Ni 26, ndio? Hiyo iko chini. And then we have a matatu. So, if they go once, bus will carry 26 people and a matatu will carry 18 people. But in total, they carried 502 people. So, in one trip, if the bus has 26 and bus has 26, matatu has 26. If they go one trip, they will carry 26 plus 18 people. 26 plus 18, which are 44 people. So 44 people are carried in one trip. They just go. They carry 44 people. What about 502 people? How many trips will they be carried? It's 502 times one trip divided by 44. We want to get the number of trips the bus and the matatu made together. Remember, the matatu made the one last trip alone. So how many trips did they make together? You will divide 502 divided by 44. So long division, 502 divided by 44. 44 goes into 50 once, which is 44. 44, which is 44. Remainder is 6, bring down to 62. Then 44 goes into 62 once, which is 44. If you subtract, 12 minus 4 is 8. 5 minus 4 is 1. Because we borrowed 1 from 6, you remain with 5. That is 12 minus 4 is 8. That is 18. So we have 11 trips, remainder 18 people. So the bus and the matatu went for 11 trips. Then this is the last trip, which we are told that the matatu carried, the last trip, 18 people. So what does the question say? How many people altogether did the matatu transport? So matatu transported 11 trips, and in each trip it carried 18 people. 18 by 11 is 198. This is 18 times 11, 8181, 198. So the matatu together with the bus as it carried 26, the matatu carried 18. But the matatu carried a total of 198 in the 11 trips. Then remember there are 18 people remaining. That was done by the matatu in the last trip. Therefore, the total number of people the matatu carried were 198 plus 18. This is 216 people. I hope we are together. But if you are asked, how many people did the bus carry? So the bus simply carried 26 by 11. This is 280, 286. Is it? 286. 286. So the bus alone carried 286 people carried by the bus. Then this one were carried by matatu. So the question wants, how many people did the matatu carry? The matatu carried 198 people in 11 trips, plus 18 the last trip it made. So it made 12 trips. Question 18. Question 18. During a celebration, there were 90 men present. There were 50 more women than men, and twice as many children as adults. What was the total attendance? So this is simple. Just write men, write women, then write children. So during a celebration, there were 90 men present. Then there were 50 more women than men. So if women were 50 more, which means 50 more women than men, which means there were 50 plus 90, which is 140. This is 90. Then, and twice as many children as adults. Twice as many children as adults. Adults were how many? 140 plus 90. So this is twice 230, which is 460. So the question wants how many people were in attendance, the total number. So just write 90, add 90 men plus 140 women plus 460 children. So this gives 460 plus 140, 0, 630 plus 90, 690 people. So the total people who attended were 690 people. 230, 690. Two more questions and we are done. Question 19. Question 19. 3 clocks. This one is very common, and this one can also bring a big problem to even people who are ahead, but very simple. It's just an application. 3 clocks were set to ring at intervals of 6 minutes. 3 clocks, intervals of 6 minutes, 15 minutes, and 24 minutes. If they rang together at 11:50 p.m., if these clocks rang together at 11:50 p.m., when will they ring together again? These are 3 clocks. So these 3 clocks, they were ringing at interval of clock number 1, clock number 2, clock number 3. One rings at 6 minutes, then another one 15 minutes later, then another one 24 minutes later. But they rang together. First of all, they started together at 11:50. When will they ring together again? Okay? So we have 6, 15, 24. This question just is asking you about LCM. So find the LCM of 6, 15, and 24, and it will be in minutes. Then you change into hours. Then we see when next they are going to ring again. So the LCM of 6, 15, and 24, you start with 2, 2 here, 3. Bring down 15 because there will be a remainder, 2 here, 12. Then go to 2 again. It goes into 3 but with a remainder, so drop 3 down, drop 15, then 2 goes here 6 times. Then go to 2 again, drop 3, 15, 3. Then go to 3. 3 here once, 3 here, 5, 3 here once. Then go to 5. 5 once, 5 here 1. Then drop 1 down. So the LCM is 2 times 2 times 2, which is 8. Sorry, LCM is 2 times 2 times 2 times 3 times 5. So this is 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 24. 24 times 5 is 120. This is 120 minutes. If you convert 120 minutes into hours, you just divide by 60. So 120 minutes divide by 60 minutes, you get 2 hours. So if these bells rang together at 11:50 p.m., remember you are in p.m. 11:50 p.m. is almost midnight. It's almost crossing to a.m. You have to be very careful because in your choices, you will be given same answers, 2 answers which are the same but only differing with a.m. and p.m. past midday or midnight, and AM. Okay? After morning. So, if it is 2 hours, and this is 11:50 p.m., add 2 hours to it. So 11:50, you go to 12:50, then 1:50. But is it AM or PM? It is AM because it is crossing over from PM to AM. It's almost past midnight. Okay? So these bells, if you add 2 hours here, they'll ring together at 1:50 AM again. Okay? Or simply add 2 hours into 11:50, you get 13:50 hours. Then subtract 12:00 hours. You'll get 05150. But what? Think that's clear? 2 more questions. Question 20. What is the value of, this is combination of fractions, 3/5 of 5 1/3 plus 6 2/5. These are mixed fractions. This is a proper fraction. These are mixed fractions. Divide by 1 1/3 minus 1 and 1/5. Simple rule is BODMAS. But before we do BODMAS, these fractions are mixed fractions. Change them into improper fractions. We said an improper fraction is a fraction where the numerator is bigger than the denominator. A proper fraction is a fraction where the numerator is smaller than the denominator. So first of all, let's change them into improper fraction to make us solve this question so easily. So this is for 3/4. It remains the same because it is a proper fraction of, when you want to change 5 1/3 into improper fraction, just multiply 5 times 3. 3 times 5 is 15, plus 1 is 16. So it is 16/3. This fraction can also be written like this. If you divide this, you will get 5 1/3. Plus, this is 5 times 6 is 30, plus 2 is 32/5. Divide by 3 times 1 is 3, plus 1 is 4/3, minus 5 times 1 is 5, plus 1 is 6/5. Then apply BODMAS. Bracket, we don't have a bracket. Of, we have of, these two. So it's 3/4 of means times 16/3. So solve this first. 3 here once, 3 here once, 4 here once, 3 and 3 cancel, 4 here once, 4 into 16, 4 times. So we have 4. So this gives us 4. This value gives us 4 plus 32/5 divided by 4/3 minus 6/7. Bracket of is there, then division. We've finished with of this, then division. So we divide these two. So be careful here, class. When dividing 32/5, divide by 4/3. You get, just rewrite the first value, 32/5. So when you divide this number, you replace division with multiplication sign. When you replace this, you change the reciprocal of 4/3 to be 3/4. Again, 32/5 divided by 4/3. You maintain 32/5. But divide by sign you change with the times. Once you replace divide with times, then you get the reciprocal. Means that 4/3, reciprocal of 4/3 is 3/4. You multiply by 3/4. So by cancellation, 4 goes here once, 4 goes here 8 times. 8 times 3 is 24/5. Then replace it. The first value is 4. Then we've solved this, which is 24/5. So plus 24/5 minus 6/5. This is a whole number. This is improper fraction. So bracket of, we've dealt with of, we've dealt with bracket, we've dealt with of and division. Multiplication is not there. So we go to addition. So addition, you add this first, then we subtract this. So when we add this, we'll get 4 plus 24 over 5. Just put 4 over 1, then get LCM here of 1 and 5 is 5. 1 goes into 5, 5 times. 5 times 4 is 20. Plus 5 into 5, 1. 1 times 4 is 24. This gives you 20 plus 24 is 44 over 5. Do not simplify it because we want to subtract this. So this gives us 44 over 5 minus 6 over 5. Again, get LCM, which is 5. 5 into 5, 1. 1 times 44, 44. Minus 5 into 5, 1. 1 times 6, 6. So it is 44 minus 6 is 38. Divide by 5. So the answer is 38 divided by 5. But you must simplify it. You can't leave it in this improper fraction. You leave it into mixed fraction. So divide this, which is 38, divided by 5. 5 goes into 38 7 times, which is 35. Then you subtract. So the remainder is 3. So when you write a fraction of this is a whole number, 7. Then this is a fraction, 3 over 5. So this is the answer. Again, 7 is a whole number. You take 3 over 5. If you multiply 3 times 5 times 7 is 35. 35 plus 3 is 38 over 5. So this is a simplified form. Then we go to question number 21, the last question. Then I'll tell you what's next. So this is also a very common question. Which of the following numbers has the smallest value? Which of the following numbers has the smallest value? Now, when you are given numbers, you've been given choices A, B, C, and D. You've been given numbers. Then you are told which of those numbers has the smallest value. So, create a column for these numbers. In terms of, we are talking of value of numbers. Therefore, we have ones, tens, hundreds, thousands, tens of thousands, hundreds of thousands, then millions. But because all the numbers are 6, just create a column. We have 6 numbers, 1, 2, 3, 4, 5, 6. So that is ones, tens, hundreds, thousands, tens of thousands, hundreds of thousands, then million. Okay? So, what are the numbers that are given? Just write them down. The first choice A, you've been given 2, 2, 2, 0, 2, 0. Remember, there are 6 numbers, so we don't need this million. There are 6 numbers. Then the second choice B, you are given 2, 0, 2, 2, 0, 2. Then choice number C, you are given 2, 2, 0, 2, 2, 0. 2, 2, 0, 2, 2, 0. Then choice number D, you are given 2, 0, 2, 0, 2, 2. So, which of the following numbers has the smallest value? Smallest value. So the numbers have 6 digits. So those 6 digits, start naming them from ones, tens, hundreds, thousands, tens of thousands, hundreds of thousands. Then you've been given these numbers. So you are told which number is the smallest here. So start by the highest, hundreds of thousands. all of them has hundreds of thousands. So in hundreds of thousands, they all have 2. So they are okay. Then go to tens of thousands. Tens of thousands, this is 2 and this is 2. So they are bigger than this. They are bigger than this and this. Therefore, you start by eliminating this because it has 2 and it has 2. Those are big numbers. So you eliminate them. So once we eliminate these 2, we are only looking for this and this. So which one is a smaller one? Then go to the next one, thousands. So in this one, thousands, they have 2 and 2. So they are still equal. So we go to next, hundreds. In hundreds, we have 200 here and we have 0 here. So 200 is bigger than 0. So definitely this is the answer. It is smaller. So this is the smallest number. If you are asked which is the biggest number, the biggest number, again you come back. So smallest number is 202022. What about the biggest number? Biggest number, come back here, look at hundreds of thousands. They are all the same. Then tens of thousands. Tens of thousands, we have 2 and 2. And we have 0 and 0. So again, we eliminate these 2 because we are now looking for biggest. So we are looking for this and this. So this and this. So 2 and 2 are the same. Come back here again. In thousands, we have 2 and 0. So 2000 is greater than 0. Therefore, the biggest number is this. So the biggest number is 222020. So class, I want to take this opportunity to thank you very much. We'll stop there for today. Then the next topics that we'll deal with the questions, I'll let you know in due course. Also for the KCSE candidates, we'll also tell you what to do. Previously, we did revision in 2020, so we may decide to premiere some of the topics that we did in 2020 together with some of the questions that we did then, so that it can help you in your revision. And God willing, next year, we'll be lecturing at the University of Nairobi. We'll be lecturing actuarial mathematics. So I wish you well. Saizi sasa ni mambo ya elimu. Remember, I'm the only person in this country who is providing free education. Hata serikali sioni kama wanapeana hiyo. And we will proceed to provide free education. The help that we can accord you, will highly accord you without paying for anything. God bless you. Asanteni sana na tuko pamoja. Tibim. I wish you all the best.